you have the floor.
Right. So you mentioned John already. So my name is Michele Pasin. John Bradley is the co-author of this work. He's now retired, but he's actually very active still, especially in the digital prosopography area. I was just chatting with him the other day, and he will be very happy to hear from you guys if you are interested in the work he's currently doing. And I'll give you some pointers about that at the end of my presentation. So right, so the title of this is Prosopography and Computer Ontologies towards a formal representation of the factoid model by means of ACDH-CH. Right, so the talk focuses, of course, on the discipline of digital prosopography, and in particular on one very specific approach in digital prosopography that John, I, and other people at King's College have been developing in the years, called factoid-based prosopography. So I'm going to describe in a few words what we mean by factoid-based prosopography, what is the conceptual model behind this approach, and how it's become a key tool for constructing prosopographical databases. However, as you're probably very aware of, nowadays it's not a really good idea to work in isolation, especially when building a database. So web technology allows us to connect to other possibly related resources, and it allows us to do it so easily that it has become imperative when designing a new digital resource to think in advance about the issues of semantic interoperability. What that means is being able to integrate our data with others and letting our users access our data in a programmatic fashion. So one of the enabling technologies in this case are formal ontologies. So in the second part of the talk, I'll describe some efforts to move our factoid-based approach towards a more ontology-compliant format, and specifically how we did that by extending a well-known standard for cultural heritage data called ACDH-CH. Right, so prosopography, as we know, is a branch of historical research that traditionally has focused on the identification of people that appear in historical sources. Pre-digital print prosopographies, such as Martindale's prosopography of the later Roman Empire, presented its materials as narrative articles about the individuals it contains. So this figure here shows a typical brief article for someone identified as Eucharius number 4. In this article, Martindale tells us a story about this person, mostly based on information he found on the Sidonius Apollinaris Epistolae, that is the letters Sidonius Apollinaris wrote. So even within the rather terse style of this rather brief article, one can see the complexity and subtlety of narrative playing a role. However, a closer look at these articles reveals also a rather formal, structured text with a carefully defined kind of interest. Dates and dating, of course, information about in which texts the person appeared, but also titles and offices the person held, places with which he or she is associated, other people with whom he or she had connections, and so on. So objects of interest begin to emerge from the text that can provide the basis for a data structure to manage them. So since the, I would say 1990s, so it feels like ages ago by now, yeah? King's Department of Digital Humanities has been involved in the development of several structural prosopographical databases, which focus, for example, on the Byzantine world, Anglo-Saxon England, medieval Scotland, and more generally, Northern Britain. So across the diverse range of structural prosopographies that we have worked on, a certain set of core interests, and therefore structural elements, always appear. So titles, people held, or relationships between individuals, they seem to be very, very common. In other projects, of course, historical events that people took part on are much more important. Other types of structural elements are instead specific to certain contexts, such as transactions, which are usually found only in projects that deal with charters. So in general, our experience has led us to believe that certain elements of structure represent key interests in the mind of historians as they carry out their work. So being able to codify these structures with the help of computers not only allows us to look up a particular person or event quickly, but also to use the database to approach this information from a whole range of different perspectives. But it hasn't been always easy to sell the structural prosopography approach to our project partners. Narratives remain a powerful mechanism to present historical research. For example, due to their ability to be multidimensional, complex, nonlinear. So downplaying or eliminating narratives about people is often causing historians to worry, and rightly so, especially if we take the wrong approach of using the database as the surrogate of the original documents. And it is precisely in this context that the factoid-based prosopography was first developed. So oddly enough, the word factoid was coined by Norman Mailer in his 1973 biography of Marilyn Monroe. So Mailer described a factoid as facts which have no existence before appearing in a magazine or newspaper. So in a similar fashion, in our prosopographical model, the factoid represents the spots in a primary source where something is said about one or more persons. It links people to the information about them via spots in primary sources that assert that information. So you will probably have noticed the ironic flavor of the name factoid, and that is intentional, and it reflects the concern that historians often have towards the veracity of sources, since the action of taking materials out of context has to be done with extreme care. So by creating factoids that assert things about what sources say about people, the factoid approach prioritizes the sources rather than the historians reading them. Our information about a person, then, is not so much a narrative that presents a summary written by the prosopographer, but it's instead more like a collection of quotes, or what the sources say about this person. Perhaps the source is thought to be a forgery, or a statement that arises out of what we consider now prejudice. So factoids, however, represent what a particular source says on its own, rather than what we now believe is arising out of our reading of a range of sources. For example, if two sources contradict each other, two contradictory factoids will be recorded. For this reason, we call the factoid model source-driven. So in this figure here, you can see a simplified version of a data structure diagram that describes this approach. The central bit of text from the story that is a subject of this factoid describes an event that connects together different individual people and places, but these entities are not attached directly to the source object at the bottom. So factoids allow us to maintain a fundamental separation between sources and the assertions we identify in them. So this is instead a screenshot of the user interface of one of our recent prosopographies, POMS, the People of Medieval Scotland. This webpage shows all the information available for a person, Adam of Eccles. You can see highlighted here in red the different types of factoids associated to this person: transactions, title factoids, witnesses factoids, and for each of them, the sources they have been derived from. And here are instead some statistics to give you an idea of the incredible amount of work historians put into these projects. And to some extent, this reinforces our assumption that the model we have been using, the factoid model, the factoid metaphor, suits their data collection activity. So we have been able to use it on a number of projects in spite of the very diverse nature of the sources being analyzed, of the historical periods and culture being studied, and also in spite of the different types of scholars we worked with, which is obviously another very important factor. Now, talking about factors, I mean, doing a little bit of a one step back, I think it's important to remember that our models do not exist in isolation, but rather, as McCarthy reminds us, they exist within a specific context. And for that reason, they always have a purpose, be that explaining a phenomenon or designing a digital artifact. So we should take one step back and review the role and purpose of the factoid model in the context of our projects. So from the point of view of the digital prosopographical projects we've been dealing with, we were able to identify 4 main areas where models play a key role. So in the data acquisition phase, models need to reflect experts' workflow and conceptualization of a domain. In the data storage area instead, models must comply with principles of efficiency and costs. In the data presentation, or maybe I should say in the information architecture area, models should facilitate finding information and making sense of it in a way that reflects the discipline's discourse. Finally, there are models that are more suited in the context of data integration scenarios. For example, because they are more easily shared across different teams and projects. So What do we mean by the data integration and semantic interoperability scenario? Essentially, that's the ability of merging data that come from different sources in a meaningful and useful manner. So for example, we can think of a scenario where two of our recent prosopographies both happen to deal with people who lived around the border between Scotland and England. Yeah. In this scenario, we can easily have persons, for example, our friend Adam of Eccles, that have the record in both databases. So ideally, we would like to be able to connect these two records across the two projects that happen at different points in time. Yeah. And so the associated factoids related to Adam of Eccles also we would like to be able to recollect and extract via a single operation. So we realized that it was precisely this aspect that we needed to investigate further. As it turns out, the factoid model was used successfully, sometimes with minor revisions in all the other areas, but the data integration one. This is due to the fact that the factoid model we developed has a certain degree of vagueness, of ambiguity, if you like, in particular from the point of view of formal logic. One could say that the same feature that made factoids appealing to historians somehow contributed to making this data structure a bit opaque for those computer or information scientists who wanted to access and make use of our data by integrating it with other datasets which are available in the emerging semantic web. So let me clarify this problem with another example. The example doesn't focus on factoids directly, but on the computational representation of persons, which, as we have seen, are normally linked to factoids. So in this case, we have two databases containing information about the same person, Adam of Eccles, but each database represents a concept of persons using a different and partially overlapping structure. So the first one has a name and surname fields, while the second one has a name and place name fields. So the issue here, the problem is, how can we integrate this type of information using a tolerant approach? That is, an approach that doesn't force one model to collapse into another or any information to be lost. So one possible solution here is to use a model which is more abstract, a model that separates the identity of persons from their names through another entity called appellation, for example. So the appellation entity can thus be extended so to include both databases' representations of names. And this is not just a possible solution, but a useful one as well, because it doesn't exclude any interpretation of the person in question, but rather it includes them within a more comprehensive model. So as a result, the model that integrates the two different data sources provides us with a more abstract and application-independent perspective on the meaning of the data. We can also say that this perspective embeds an ontological view of the world, a view that aims at being as far as possible general and reusable, so to say, rather than being dependent on specific application scenarios. So now, provided we could express this model using a formal language, a language that computers understand, what we see here could become part of a computational ontology. In general, then, the discipline of formal ontology provides us with a theory of how to make categorical distinctions in a systematic and coherent manner, to the purpose of creating models just like this ones, models that can be used like semantic glue, among other more application-specific models, just like in the name examples we have just seen. And indeed, the model we just described, the one that separates persons from their names, is taken from a well-known ontology called the ACDH-CH. So this ontology was initially built in 1996 as a means of maintaining interoperability among museum data, but has been found to be of interest to historical projects more generally. And in fact, as we will see later, we will be able to use it in order to generalize the factoid notion itself. So the model has improved a lot since it first came out, till becoming in 2006 an ISO standard. It includes concepts and relations describing people, organizations, places, events, physical objects, and conceptual ones. And in particular, one of the most interesting features of CDOC is its event-centered design. What this means is that temporal entities tend to have a central role in any CDOC-compliant dataset. That's because although we have many different kinds of entities in CDOC CRM, such as persons and physical objects, CDOC's models forces us to describe them by including them within one or more events. So moving back to our factoid-based prosopographies approach, if we want our data to be more interoperable, we must express its semantics by means of a data language that uses less arbitrary notions than the one of factoids. In other words, how can we model the factoid notion using a more ontologically sound approach? What do we really mean when we talk about factoids? So the solution to this problem can be found by breaking down the factoid idea into other ideas that are simpler, that are more primitive. So using this approach, we concluded that each time we create a factoid, really, we imply the existence of three different core entities: a person, who is the author of the factoid, the document that contains the factoid, and a state of affairs, that is what the factoid is about. And that, in a nutshell, appeared to us as the fundamental ontological structure of factoids. We can, of course, expand this a little bit more. For example, by saying that most of the times, the state of affairs, the things that the factoids are about, are either a situation or an event. So situation, a kind of a state of things which is rather stable in time. An event is instead something that happens within a much more definite time span. So, but there is still something missing in this picture. We have broken down the factoid notion into smaller components, but the three entities are not really related to each other as such. So on the other hand, when we create a factoid, we kind of generate, we maintain meaningful connection among them and actually say something about that connection. We need then to represent also the implicit act of associating them together into a meaningful unit. So for that reason, we introduce another concept in our model, the concept of interpretation, which can be defined as another temporal entity with a very specific structure. An interpretation has an author, the person who carries out that interpretation. So for example, in our case, Martindale, John Martindale. An interpretation has an object, the thing that is being interpreted or read, in our case, a source document. And finally, the interpretation has a subject. That is the content of the interpretation, what the authors say about the document. So in conclusion, we have now obtained a much more precise and transparent formal model of factoids. This model could be used in order to encode our prosopographical data and make it available to other people who are not necessarily familiar with the factoid notion. In other words, by encoding our information using this model, we would definitely improve its semantic interoperability. It would be easier for other parties to take our database and merge it with other projects or other databases. But we can do even more than that, right? So in order to increase the semantic interoperability of our model, we decided, in fact, to express it using the formalisms offered by the CDOC CRM ontology. Since that's a well-known standard for expressing data models, it will make it even easier for people to consume our prosopographical data. In particular, there is a concept in CDOC CRM called attribute assignment. They seem to be quite suitable for representing our notion of interpretation in the context of factoids. So an attribute assignment is defined in CDOC CRM as a temporal entity. So something that happened at a particular time at a particular place, and its stated purpose is to represent actions of people making propositions and statements during certain museum procedures. For example, the person and date when a condition statement was made, an identifier was assigned, the museum object was measured, etc. Of course, this was clearly defined for a museum setting, and that's consistent with the stated purpose of CDOC CRM. But we thought that the structure of this class, the structure of these concepts, and its semantics match very well our document interpretation concepts, which can then be thought of as a more specialized version of it. In other words, a subclass of an attribute assignment. So, wrapping things up, this is the resulting model. Our factoids, sorry about that. Our factoids will be transformed into document interpretation acts, which are activities that are carried out by actors and assign state of affairs to documents. That is to say, factoids say that a document is about a certain state of affairs. So in general, we have been implementing this model quite a lot, and we've been quite happy with it, and in particular the CRM rendering of it. But it doesn't really end here. I'll quickly show you now a couple of interesting open issues that also derive from this approach. First of all, in the factoid approach, the relationship between a source and the assertions made in that source was supposed to be as literal as possible. In other words, the scholar creating the factoid should avoid doing any interpretive work. He or she should just replicate the assertions made in the source within the database, so to make it available as is to end users as much as possible. We felt that this aspect isn't really captured well by the semantics of the CDOC-CRM assigned relation, because in theory, any kind of interpretation, not just literal interpretations, can be assigned to a document. So maybe we should extend the model by introducing sub-properties, essentially more specialized versions of the assigned relationship, such as is literal evidence for or claims. So properties that are able to express this meaning more clearly. Second, if we take this consideration one step further and start thinking about the interpretation connection strength as a variable in itself, we can essentially come up with a rather different way of thinking about things. It becomes plausible to have a range of possible relations that we can use for defining factoids. We could organize these relations within a continuum, for example, in order to characterize more precisely the truth value of the interpretation we assign to a source. So we might decide to have three possible evidence relationships, for example, according to pre-agreed degrees of certainty which historians may have. Something is definitely a literal interpretation of the text, something might be an interpretation of the text, or something is rather unlikely an interpretation of the text, something like that. And of course, this reflection opens up a path towards modal logic, because it leads to the creation of claims such as document X may be about situation Y. And actually, we've tried out this approach a couple of times, not with ontologies, but with more straightforward relational databases. And we know that historians, they actually like this a lot. They can certainly make use of this type of claims. The interesting question, though, then, is how do we treat them within the database when searching for things or for performing inferences based on existing data? So it goes without saying that this opens up a whole range of new issues. And finally, this line of thinking can be even taken further, to the point that we might as well want to introduce negative claims into the picture. For example, by letting historians say, according to document X, event E never happened, something like that. So in this case, we're actually abandoning the strictly source-based approach of factoids, since these are all inferences, speculations made by the historian or the scholar based on background knowledge. But of course, this conclusion is inevitable as long as we decide to move towards an ontological model of interpretation. So, wrapping things up a bit. Essentially, during my talk, I touched on three fundamental points. So first, I've shown you that the factoid model approach in structural prosopography has been a pretty successful one. It has a pretty wide applicability, and we have proven that by using it many times in different projects over the years. Second, I've talked about how it can be ontologized, in particular by making use of CDOC-CRM, and why we have done that, fundamentally to enhance the semantic interoperability of our data. And finally, I've shown you that although ontologies are brought in primarily to help with semantic interoperability and conceptual clarity, they can also open up new and interesting challenges, such as the ones about modal logic and negative statements we have just looked at. So I'm aware that all of this was a lot of theory and very abstract. I hope it gave you an idea, a pretty clear idea what factoids are and how they can be expressed using other standards that you may already be familiar with. So in these last few slides, I only have a couple of extra slides here, and then I can jump off to a website where you can see a specific implementation of the prosopographies we have been developing using linked data standards, using RDF. So one starting point for all of this is the Factoid Prosopography ontology that my colleague John manages. This contains a whole range of a lot of information about the factoid model, and specifically one implementation of the factoid approach using OWL. So I really invite you to take a look at that for more information about that specific formalizations of the factoid approach. Second, there are a couple of linked data repositories of our prosopographies that can be used in order to explore the data and to see how the factoid model translates into actual queries and data shapes that you have to familiarize with if you want to bring those data into your environment. So one of them is the People of Medieval Scotland endpoint, and I'm going to actually jump into that in a second. And the second one is the digital prosopography of the Roman Republic endpoint. So both of these are essentially a full transformation of the prosopographical databases into RDF. The prosopography of the Roman Republic was done at an earlier stage, and in practice, it doesn't really reflect the factoid model too much in its RDF version. It was more of a direct translation from a SQL database to an RDF format. Still, it has been used by different external projects and scholars in order to pull the data into their own work. So it's quite an interesting project. On the other hand, though, the People of Medieval Scotland endpoints, that really contains the factoid model as I described it. And it allows you to query it using Sparkle and the RDF standards that I'm sure you'll you know lots about by the end of this week. So I'm going to give you a quick walkthrough of this resource. Let me see here. Can you still see my screen, the browser window? Hope so. Yeah. Okay. Good. So there's a whole section about documentation, the data model being used, some background information about RDF, which I will just remind you is the kind of standard language for the web of data, and it's a language that fundamentally relies on a triple, on this notion of a atomic unit of information, which is expressed by the combination of a subject, a predicate, and an object. I will jump straight to the Sparkle examples page. So Sparkle is the official query language for RDF data. And as you can see here, there are a number of sample queries you can play with in order to explore this data a little bit further. So this is a simple query that essentially pulls out all the possible roles. Oh, wait, I'm getting a message here. All right, okay, I got that. Okay, Eric. So this is a query that pulls out, let me try and make this a bit bigger, right? So People of Medieval Scotland is a database of people who lived in medieval Scotland, obviously, and most of the information comes out of charters. And we have a huge number of roles, essentially describing the situations these people got involved in. And if you use the People of Medieval Scotland website, you can filter data using roles. So I can say, show me all factoids or charters where someone was actually a witness. But it's actually really hard to pull out a full list of roles because that's not really the main object of interest for the database. Instead, by making the data available, by making the raw data available as such, it actually becomes trivial to do that. And so what I'm doing here, I'm simply saying, find me all name and the URI, the unique identifier of a role, for objects that have type role. Vocab is a prefix that refers to the POMS ontology defined here. And I'm also pulling out the name for every role that is being found. So I'm going to execute that query, and what comes back here is a long list of all the roles that are to be found in the database. Of course, that's just a starting point. We can have more interesting queries, or queries that try to answer actually useful questions. In this case here, we have a query that selects all women. So we have a class defining historical females. So for all females, we also extract the name and the dates when this person was known to be alive. So we can try and execute that query now. And here you go, your list of all the women available in the POMS database. Of course, all of these links you can click on, and you can essentially follow up the linked data model by looking at all the other triples that have this specific URI as a subject, as I'm sure you guys are already familiar with. Now scrolling down a bit more, we have some more interesting examples. Again, here we're not just pulling out women in the database, but women who have a specific role. So essentially, we are taking advantage of the roles query before. We know the URI for grantor for that specific role, and we can only pull out women that have that appear in factoids that have essentially with that role. Here I get my list of grantor names. These are the IDs. As you can see, the same person is repeated multiple times because it appears in multiple factoids. So if now I open up one of these links, that's one of the factoid URIs. Let me scroll down here. Of course, there's a number of types, essentially logical types of that class, human readable names. We have dates for the factoid. Key relationship here has source. That's the charter the factoids derive from. And then other classifiers of the factoid. So for example, here saying that this factoid has another type. Let's see what this is. It's a resignation. And I think quite interestingly here, I also have this factoid is also actually related to other factoids. Yeah. So this factoid here has a number of person reference factoids that are related to it. So if I open up one of them, this is most likely because in some other source, in some other charter or some other document, the same event, the same resignation event was mentioned. So in this case, these two factoids are related to each other. And of course, this is a really granular view of the data behind it. But you know, what this makes me think of right away is to pull this data out and represent it as a network. Yeah, yeah, multiple factoids related to each other, so it will be natural to kind of build this graph showing how the different events are interacting with each other and what are the persons that come into play in the context of these events.
I personally would wonder and well, expect usually problems from people considering this double encoding in the Factoid model. So having the information about the people separate from the people somehow, or in this kind of reference to a documentation? Did you encounter problems with this? So you have to do usually this kind of intermediate step, saying, okay, I'm doing an assertion about the person. Was this problematic, or is this so easy to grasp that query is becoming fast?
You mean by intermediate step, the fact that you have something in the middle?
Yeah, so that you get the information to the person, not directly to the person.
No, I don't think it was an issue, and simply because what you have to think of is that this is how the computer sees things. So this is the model we use in order to structure the information we have about people. But when users actually navigate a web interface, when users trying to discover information, they don't really see this kind of complexity. To them, they always, look up a person, and then they find all facts related to that person. All I'm saying here is that, as I was trying to explain earlier, models can be fine-tuned and partially hidden to the purpose of the task you're dealing with. So if I'm focusing on data presentation here, I can essentially hide that sort of factoid abstraction because people don't care about it, and that's perfectly fine. And that's also why we thought that the factoid model was okay in that sense, because essentially it's always easier to hide something than to add it on if you don't have it. So the data presentation side of things was actually okay, it was fine. On the other hand, when it's time to do data acquisition, in our experience, historians, they quite liked the idea of factoids. They liked the idea of being able to separate out the level of what the source says from the actual people, objects, and places being mentioned. But there as well, I think there is an aspect of UX, of user experience, which is crucial. Meaning that if you these days you can get a lot of pre-packaged data entry tools that essentially you just feed them like an ontology or something like that, and they give you a bunch of drop downs and fields to fill in. But these drop downs and fields and pages, they look exactly like the ontology, and that means they're not really user friendly from the point of view of a scholar trying to input the data. So this is to say that we put quite a bit of work in making the data entry interfaces usable. And that's another key aspect, I think, of all of this. So the data model, having an abstract data model, it's a powerful mechanism of being able to, of future-proofing it, of doing, of allowing different projects or different approaches to be built upon it. But at the same time, you have to do quite a bit of work to make sure that the data model you have suits the different needs people may have. So that'll be yeah. Oh, I see. There's a question.
There's 2 questions. You want to read it out, or?
I will.
Yeah. Well, let's do it, Sanja, here in the room, that the moderators feel a bit involved. Okay.
Good.
Okay, Sanja.
So I feel like I do something. So Francesco Pereda asks if you shared your modeling patterns of the information types, like, for example, the authorship, the education, event, personal relationship, and so on.
Yeah, that's a very good question. We started to do that. It's by no means complete. I will add a link to the slides, but this is something I started working on. This is an ontology called feudalism, where essentially I try to go through systematically all the different information types, transaction types, event types, and to build an ontology tree out of it. Not perfect, and fundamentally because things are not always clear cut. Ontology and logical systems, they tend to want things to fall within very precise buckets. You know, if something is an adultery kind of event, it cannot be, I don't know, something else. In practice, every time I was showing these to historians, they were like, I'm not really sure, you know, I would put this event in 2 different buckets. So that essentially led us to believe that maybe we shouldn't over engineer this too much, and to have a rather maybe flat structure, a little bit more like tags, and allowing people to not really like tags, it's more like topics related to each other, but then really allowing people to decide what topic to use quite freely. But yes, if you want to have a computer readable representation of those information types, you can get it here. It's not final, but it's something you can work with. I'll add this link to the slides, yeah, and I will update the slides right after this.
There was another question.
Francesca, I hope the question is answered for you.
If not, how does your hand again?
Yes, thank you very much. I come myself on this topic tomorrow, so I'm happy to hear you working on this. Thank you very much.
No problem. Yeah, you're welcome.
Then we have another question from Becca, who asks, for site of CRM, it's reasonable to assume that an object exists, but are there maybe some prosopographies where this is not true? For example, if we have Elcherius 4 and Elcherius 3, if we can know if it's the same person or not. And is this a problem for site of CRM, if I understood the question correctly?
Yeah, I think now I hope I'm interpreting this correctly. Yeah, I mean, talking about interpretations. Let me go back to the slides here. Hold on, bear with me. So, whatever, it doesn't matter. Let's go to one of these. So I guess, I mean, CDOC CRM, I mean, yeah, of course, the ontology, I mean, that's a really nice way of summing it up. You know, the authors of CDOC CRM, they say this is a model that allows computers and people to reason about identity and existence clearly, because, you know, it allows you to say things about things, and you can build up a network that tells you know what existed when. But that's different from existence in an ontological, in a, you know, human's ontological sense, you know, saying that something exists for real. You always have to define a universe of discourse. So thinking, what is it that I'm talking about? What is it that I'm trying to model here? So normally with factoids, with digital prosopographies, what we model is essentially what we find in sources. We say that Martindale said X. We don't really say whether that is true or not, or whether this X existed. We just try to essentially replicate what we find in a medium onto a different medium. That's all. And that's why the factoid model, in a way, something that historians liked, because they weren't really in the business of making new history there. They were simply building a new resource that was replicating what has already been said and doing this at scale. Then, of course, afterwards, once the digital prosopography is complete, people can use that as an essentially another tool to make assertions about the history itself. So in that sense, I think the question of whether CDOC CRM suits itself to representing the truth or whether object exists wasn't really an issue. It wasn't really an issue in our case. So the, you know, Martindale might have been wrong about Eukaryotes 4, maybe it was another Eukaryotes. It doesn't matter. We just say that essentially that's what he says on that page of that source. And I really hope I'm addressing your question there. I'm a little bit concerned that maybe it's not what you were asking for. So apologies for that, if that's the case.
Yeah, Becca, you can speak up if you want to reframe the question.
No, that's absolutely fine. I just wanted to confirm, because there's a lot of us are doing original prosopographies. We don't necessarily have Martindale as a separate person. I was just interested to hear what you said, because it was very clear from what you said is that this model is reliant on having someone stating that assertion, and that somehow that is a separate stage. But no, that made absolute sense. Thank you.
That's actually extremely interesting. We never had to deal with that situation of historians doing original prosopography. And so I'd love to hear more, well, probably not now, but feel free to reach out more from you if the Factoid model can help at all in your case. I mean, in your case, clearly you have to say something about the veracity of what you say, it seems to me. So that's quite interesting. So maybe that's where the Factoid model breaks down. Thank you.
There's another question from David Moda. If you ever tried to use the Factoid ontology to actually integrate data coming from prosopographical projects, which used different models than the Factoid model?
Yeah, that's quite interesting. And you know what? No, we haven't really done that. We haven't really done that. And our primary concern was to essentially allow people, we just had so much data, to allow people to use that data. And for a very long time, the digital prosopographies have been done in isolation, well, so to say, in isolation, not really thinking about the larger web. So yeah, so the primary intent was to open our doors to the external world. We weren't really selling the Factoid model as an easy way of integrating data. Actually, it isn't, because yeah, it's very application specific, I would say. The CDOC CRM version of that model, essentially that interpretation of that model, I think is definitely much better in terms of integrating different prosopographical data, but no, it hasn't been done.
Thank you.
Okay. The last point is something I personally are very interested, because I tried to work with Matthias and Gunther on easy, consumable methods to integrate data from different sources with computational methods, so the interface is less, well, it's reduced, so you don't have to care about all the granularities of CyDoc CRM and the RDF, but that's something we shouldn't discuss here now, because we are closing to the next presentation, and I want to give everybody the opportunity for a break, and want to thank you, Michele, because you did precisely what I expected, to introduce the basic concepts with all the projects you really did. So we have an idea about what could be done, what has been done, and still got an idea how manifold it is in the end by all the questions. So thank you, Michele.
Yeah, it's a pleasure to be here. Thank you.
Okay.